All right, I want you to imagine something with me for a second. You're floating in deep space, just completely alone. There is absolutely nothing around you for millions of miles. Then, suddenly, this invisible, overwhelming tidal force starts pulling you in. It isn't a planet, and it definitely isn't a neutron star. It's something so overwhelmingly powerful that literally not even light can escape its grasp. What you're being pulled toward is a black hole.
Exploring descent into darkness, the physics of black holes. You know, black holes are easily the most terrifying objects in the entire universe. They don't shine, they don't reflect, they absolutely do not let anything escape. And what's truly staggering? Scientists believe there are up to 100 million of these silent stalkers drifting through our Milky Way alone.
Okay, let's dive into this. What actually happens if you fall into one? I mean, it's the ultimate question, isn't it? We know they're out there, but the mechanics of what happens when a human body meets infinite gravity, well, that's where the science gets truly wild. So let's set the stage for our immersive journey right into the unknown.
Part 1. The Cosmic Monster. Star Death and Infinite Density.
So, how does this all begin? Well, a black hole begins its life in the explosive death of a massive star. When a giant star, we're talking many times the size of our own sun, runs out of nuclear fuel, it just can't support its own stellar mass against the inward crush of gravity anymore. Following a massive supernova, the core collapses violently. It crushes down until it becomes this microscopic point smaller than a single atom. Actually, scratch that, it achieves infinite density. All of that insane mass packed into essentially zero volume, a true singularity.
Now, surrounding that infinitely dense point is a boundary, and it's called the event horizon. I want to be incredibly clear about what this means. This is the absolute point of no return. Right here, the escape velocity surpasses the speed of light itself. You can orbit a black hole safely if you stay far enough away, sure, but the second you cross this mathematical boundary, there is absolutely no coming back. None.
Part 2. The point of no return. The spaghettification effect.
Let's move forward and see how this builds. As you actually cross the horizon, the physical toll of the journey really begins, and extreme tidal forces completely take over. Because gravity operates on an inverse square law, the pull on your feet is millions of times stronger than the pull on your head. This immense gravitational gradient begins to stretch you out. Eventually, you are violently torn apart, atom by atom.
Believe it or not, astrophysicists actually have a highly technical term for this horrifying process: spaghettification. It was famously popularized by Stephen Hawking. I know, it sounds a bit ridiculous, kind of like something off an Italian restaurant menu, but it describes an inescapable, fatal physical reality. You are literally drawn into a single, agonizingly long strand of matter.
Part 3. The illusion of time. Relativity in action.
And this brilliantly illustrates the wild effects of Einstein's relativity. Time experiences severe dilation near a black hole. To an outside observer watching you safely from a spaceship, you wouldn't just vanish. Nope. As the light stretches, you would appear to slow down, shift to red, and eventually freeze completely dead right at the edge of the event horizon. But from your own perspective, time feels totally normal. You don't feel yourself freezing at all. You simply keep falling faster and deeper into the dark.
Part 4. Inside the singularity, where physics breaks down.
So what actually lies at the core? Honestly, no one knows for sure. Competing theories suggest it could be a wormhole, like a literal gateway to another universe entirely. Or perhaps it's just a dead end where all mass is infinitely crushed into a singularity. But the terrifying truth is this: whatever the singularity is, it's a place where the laws of physics, as we understand them, completely break down. The very concepts of space and time, they simply cease to exist.
Part 5. Our galactic neighbor, the monster next door. Now, this isn't just some abstract physics concept or a distant anomaly at the edge of the universe. Meet Sagittarius A star. This is the supermassive black hole located directly in the center of our very own Milky Way galaxy. Now, what's really interesting about this is its sheer scale: 4 million. Sagittarius A star has a mass of over 4 million suns. Just wrap your head around that. Imagine taking 4 million of our stars, crushing them down into a tiny sphere, and placing them right at the gravitational anchor point of our galaxy. That is exactly what's sitting right now in our cosmic backyard.
Okay, take a deep breath. Sagittarius A star is safely 26,000 light-years away from Earth. It isn't going to swallow us tomorrow. But knowing it's out there, anchoring our galaxy with a mass of 4 million suns, really reminds us just how small and fragile humanity is in the grand sweeping theater of the cosmos.
Black holes are so much more than just cosmic monsters. They are the ultimate mysteries, challenging our grip on reality, on physics, and on time itself. Maybe one day we'll finally understand what happens inside the singularity. Or perhaps we have to ask, are some secrets of the universe simply never meant to be discovered? It's a pretty humbling thought. If you enjoyed this explainer, make sure to keep feeding your curiosity, because the